Prototype, test in a laboratory, or test in a real life environment, etc. All the way up to the top, which is level 9. And we have transferred this to projects, and the idea behind establishing this unique identifier, not identifier, but unique an index that rates the project, is to simplify the decisions. At OW2, we've been looking at the quality of the the project for several years, and we've been gathering data and metrics about the project. And we realized that too much information, in fact, creates entropy and does not really help decision making. So that's when we looked at, we discovered this TRL, technology radius level scale. We thought it could be easy to transfer that to the market approach. So what we did is put together took all these different single data and established this scale from the bottom where actually the project is almost not useful at all, to the top where it's a fully supported product that a decision maker, business decision maker can acquire without thinking twice. So here is the scale. So that's our market readiness levels that we have defined. So to the right you have the reference scale from the NASA, and to the left you have our scale. So at the bottom we have projects that are basically in R&D mode, so it's only useful for the researchers or the core developers. Then it goes up to we developing a product. Then we have the usefulness, so we know what this can actually do and how it can be used. We have verified it on level 4 with several users, but just several users, so the adoption is very limited. And then we go up to growing adoption with level 5 with a fair adoptions with some customers and some recognition already. Level 6 is a project or already some kind of product with sizable adoption. And then we move into the 7, 8, and 9, where it's really more business-oriented situations, with level 7, where we actually have commercial marketing processes that make the conventional decision maker comfortable dealing with vendors and with support plans. So you can move into this projects from a business perspective. And then we have the appreciation of the market power of the product with established outsider at level 8 and market leader at level 9. What we've done, the way we're doing this is through a 3-stage evaluation. So the first stage is by looking at the best practices. We have 10 categories of best practices, each highlighted with 5 checkpoints. So we have 50 control points in the best practices, so to make sure that the project is, or the product is well supported. And the quality is respected and respects the legal compliance, what we expect. The stage 2 is by collecting data. So this is a stage that is totally automated. So we use the development environment from the project to collect all this data and have what we call attributes. So we have 5 attributes: the activity of the project, whether there's a community or active community, the compliance, whether the legal compliance is respected, the quality of the code, and the sustainability of the whole project. So we have a number of checkpoints there. We collect automatically 20 type of metrics that we combine with data from stage 1 to have these 5 attributes. That's what we call the attributes. And then the third stage is another angle. It's a market capability assessment that is established through an expert interview. And we check the position of the project against 42 market-oriented situations, all organized in 7 categories. So all in all, we have some 100 control points to establish the score. And computing the score, it goes through combining these different stages. So we have the best practices, which is stage 1. Then we combine in stage 2 the best practices with the metrics. And in stage 3, we combine the attributes we derived in stage 2 with the market capabilities. And that's how we reach this composite index. And this composite index helps us position the project. So what we've done, we've applied market readiness levels to 22 projects. That's in the OW2 code base. We run more. At OW2, our job is really to promote a code base. So this is why we are applying this to our code base. The other reason why we're applying it to the code base is that it's an environment we control, and we've managed to engage with the project leaders to be part of this exercise. So the way we publish these results is on the OW2 website. Each project has what we call a dashboard, and on the dashboard you see some of the tab of the dashboard indicates the market readiness, and this market readiness page here provides you with the data from each, the base data from, or results from each stage. And there is a little synthesis to explain and to help understand the raw figures. We published this, and before publishing this, we checked that with all the project leaders, and we were lucky to realize that, in fact, it was quite accurate and reflected what they themselves were perceiving of their own project. So, but we did that over a kind of a long period, several years. The whole thing now runs on our own dedicated infrastructure. So we started using third-party tools. We now have everything running on the OW2 infrastructure. So it's a little bit, it's simple, but it's totally under control. So the best practices is a form that runs on XWiki. Then the metrics are automatically connected through a number of software tools that we use, such as ScanCode, SonarCube, Git, and we collect data from GitHub and GitLab. And for bug tracking, that could be Jira or the GitLab bug tracking. And of course, the market capabilities is an expert interview that is also collected on XWiki. So all this goes through a data collection kind of middle layer, and it's computed, and we publish this automatically on the project download. So the project's facing, we've been running this through several, we've started this several years ago, and so we started looking at kind of metrics we could have. Then we looked at the models. We use how we collect the metrics, what I've just explained. Then how we can model all this. Then how we publish this, and now we're in stage 3 where we can actually go public and share with you what we have been doing. So that's the timeline you see here. We're in the third or fourth year actually of really doing this. Only in 2021 we've managed to actually deploy it concretely on the OW2 code base, and we freezed it for 2021, and in 2022 we will be working on the second version. So it has advantages for project users and for the project team. For project users, it helps them assess the reality of an open source strategy and be sure that the project or the product is ready for consumption. And for the project team, it's and that's what they tell us, is that it helps them double check their project. Initially, we launched this to help the decision makers, but now we realize that it's also a tool for the project leaders to identify where they could be better, they could do better, and work out their road for progress. So in conclusion, this thing has strengths and limitations, of course. First of all, it works because we've checked that with other project leaders, and they recognize that it represents, as I said, what their own perception of the project. It's useful for developers and users, as I've just said. I think it really represents, it's based on the state-of-the-art of open source expertise. It really conveys what should be done related to this, to what can be best done today in terms of developing open source software. Now, it's also completely transparent, it's open, it's not a black box. All the raw data is published, so from the dashboard you have access to all the single data that can be challenged. And we've had some questions from project leaders, and we realized that some of their data were not accessible, so that's and we could fix this. And in fact, it's pretty simple, and accessible and adaptable. Now, adaptable is important because one of the limitations is that this old methodology has been calibrated with statistical tools or approach calibrated for the OW2 code base. So for instance, it could not be applied to GitHub. And what we still want to do, yes, one thing I need to say is that it's not an evaluation of the functionality, but it's more a functional evaluation of the market potential of the project. So functionality is something different, and we really are careful not to create confusion by saying, well, this is a good project, it works well. Maybe it doesn't work, maybe it's not useful, but at least it's well done, and it's well supported. That's what the market readiness levels imply. So, and still to do, so we need to check the robustness and sensitivity of the project. And with that, thank you very much.
Thank you.
So, do we have questions? Do we take questions from the field, or do we have time or not?
From online, we don't have a question, but I forgot to mention before. If you have a question, please come here in front. There's a microphone. Please don't touch the microphone due to COVID regulations. And yeah, I think we could take one question. Please.
I don't touch anything.
Thank you.
Okay. Well, I just have one question, Cedric. You have 9 levels. And I was wondering if you ended up with 9 levels because they are all required in or you really have a strong differentiation between the levels, or is it to stick to something that will be similar to the NASA TRL?
It's a bit of both.
Okay.
First of all, because there was already the NASA TRL thing, so if we develop something parallel, we could save some explanation.
Okay.
So that's the idea. And the second thing is that we managed to actually identify true levels where we move from the project being in development stage, finding its usefulness, up to adoption, and then to the top being truly a commercial product. And there's a continuum between the project and maybe the product. Now, one thing that is important is that we concentrate, because there are many open source vendors with a commercial version and a community version, we only analyze the community version. But
okay.
Moving up to the top with the established business and leaders, etc., we are perfectly aware that here we are creating continuum between the commercial version and the community version.
Okay.
Thanks.
Thank you.
Okay, thank you. Do we move to the next one immediately, or we wait for the timing?
We have still a little bit of time, and we will wait until the others come if someone joins and switches rooms.
Okay. is Antoine Mautier. Antoine Mautier is OW2 CTO, and I'm proud to introduce Antoine. His love for technology took him from open source software vendors to research and to this community position at OW2. So I'm very pleased to introduce Antoine, and he's going to introduce us the Fasten project, and entitling his talk, Taking Dependency Management to the Next Level with Cold Graph. Antoine, over to you.
Hello everyone, and thank you very much for joining me for this presentation of the Fasten project. So I'm Antoine Mautier, OW2 CTO, and in this presentation I will try to explain how the Fasten project tries to improve dependency management by using call graph. But first, I'd like to take a step back and try to do a kind of panel of what the current solutions are available related to dependency management, how we do it, and to then present really how we try to improve it. So as you know, when we develop software today, we never start from scratch. We use a lot of libraries. We use feature, of course, of the ecosystem we developed on, but we also use third-party library, and most of them being open source. And this leads to some challenge because dependency can be quite simple at start. You might have only a few dependencies declared in your application, but the complexity can grow quickly. For example, in this illustration here, my project have 3 direct dependencies, but those dependencies can have themselves other dependencies. So you have this kind of graph that is building up with what we call transitive dependencies. And to bring a little bit more complexity here, a dependency can be at the same time a direct dependency and transitive dependencies. And you need also to deal with a version of your dependencies. So you might depend on a given version of the dependencies, but another part of your dependency might require a different version. So you can have a conflict. And as I said, the complexity is growing. We have more and more library that we depend on, and themselves have some extra dependency. So we have this huge graph of dependency building up. But what is nice is that we have toolings. We have toolings such as Maven for the Java ecosystem. We have pip for Python with the Python package index, that is a central repository where we can get the files from. And we have equivalent, for example, we can view the Debian packaging system as a way to build application to manage the dependency for the C programming language, for example. I take the example of the 3 languages here because they are the 3 languages that Fasten support. In my presentation, I will mostly highlight how Fasten help the Java developer because I'm more familiar with Java, but the same really apply to all different supported language by the project, and it can be extended to support more languages. So one issue we really face when we deal with dependencies is the security. If one of your dependencies have a security issue, it can impact your application. So you need to monitor the security of your dependencies. But as we saw earlier, you also have transitive dependency. And so you need to take a look at those transitive dependencies security issue as well, because they can propagate up to your code, your application code. So that one aspect that you need to be aware of. And you have also similar issue, regarding license. You need to make sure that the different library you are using are compatible with each other, the license are compatible and also compatible with your application. And with this growing graph of dependencies, it can be quite complex. So the first step is probably to limit the number of dependency. you don't want to deal with unneeded dependency. For that, there is already a tool that exists, for example, in the Java ecosystem. It's called Deb Clean, and it will look at the dependency you declare in your project. So for example, here, I declare a dependency on SLF4G library, and I'm using it in my application, so it will be able to find that this is a used dependency. And if I remove this code, if I don't actually use it, it will tell me that I can remove it. The trick is, if I do some specific calls, like dynamic calls that are resolved at runtime, it will trick Deb Clean tools, and it will not be able to identify that I'm actually using the library. So it'll tell me that the library is potentially unused, and potentially here is very important because you cannot say for sure. So the tool is limited here. We have a limitation. It's only potentially unused. Sorry. So we already see that some limitation exists. We have also another very popular tool that is Dependabot, and in the same way I did a test here, having a dependency on a vulnerable code, but the dependency that was vulnerable was not direct. It was transitive dependencies, and for Java, Dependabots don't give me any alerts. So that's an issue. It doesn't cover transitive dependency, only focus on the direct dependency. On the other end, we have Sneak tool that is better as dealing with transitive dependencies. But again, I spot a limitation that if I declare a dependency that I don't use, it's weird, but when you have a lot of dependency, you might include them, but not using them. It's what I have here in my example. And Sneak will tell me that my my project is vulnerable and that I should update my dependency, whereas I don't use it. So the best recommendation would be to tell me to remove it. And the same feedback is given by Dependabot or also dependency check, that is another Java tool, Maven tool. So overall, what we see is that, the toolings are lacking accuracy because they work at the package level and they don't look at the code and the actual call of the library. So this is what Fasten tried to improve. It will not only deal with package dependency, but will try to look at the actual function call, method call within the library. So we have a very basic example here. You can see the different call of the function, and you can see some function are not used. So what we do with that is that we'll enrich this graph with some metadata. We use, for example, data coming from CV central database for the vulnerability. We use license information we can get by analyzing the source code, and so on. And we enrich the call graph we built of all the function call with some extra information. This will help us then to provide the developer with additional information and more accurate information. So basically, when you build your project, for example, here with Maven, it will resolve the dependencies, and then Fasten will act as an extension. It will be actually integrated as a Maven plugin. So it's really on top of the existing dependency management tool, and it will build the call graph for your code, so for your application code, and it will be able to get the graph for your dependency from the Maven central repository. This is to improve performance. Publicly available library are processed by a central server, a Fasten central server, or it can be your own if you want. You can install it on premises, and it will then stitch together all the call graph, so the one from your application, the one for all the dependency, to have this global view of all the calls being made inside your application, and it will enrich them with the metadata, so like CV, license information, and so on. And then it will be able to notify you only of the call to vulnerable code that are actually made in your application. So if the vulnerability lies in a part of the library you don't use, it will not tell you that you need to upgrade. It will only tell you to upgrade if you are actually calling the vulnerable code. So in this way, it will be more accurate compared to tools like Dependabot or Snake that currently work only at package level. So we go one step down and look at the source code. So the big challenge here is to build this. So there are still a lot of work in progress in this area to make sure that we built an accurate call graph and to be able to identify all the dynamic function call and so on. So that was really a quick introduction of Fasten. I just want to say a few words. Also, we are actually developing this project as a European funded project, and we have a consortium of various partners. You can see the full list here. So it's some universities, some companies, some non-profit organization like OW2, and we collaborate all to build these tools that will work on top of the existing dependency management tooling. So thank you for your attention. If you have any question, I can take them now. Or also, if you are interested to learn more, you can, of course, visit the website. Also forgot to mention, but of course, it is an open source project, and all the source code is available currently on GitHub, so you can take a look there, and you can follow us, of course, on social media to get more news. Thank you very much for your attention, and now if there is any, I can take questions.
Thank you, Antoine. Thank you very much. I think we will take a question maybe offline. And do we have, I think there is a quick break. In the meantime, I invite you really to follow up the project on the website. We have 2 minutes for questions. Oh, yes, question. I think you need to come to the microphone.
Please come forward and don't touch the microphone.
Hi there, thank you for the presentation. I might not have been here to hear it, but does Fasten work with other package managers too, practically? Like NPM?
It's not a problem.
But it's just tooling, so there has to be, is there an implementation already written for NPM, for example?
So the question is about which package managers does Fasten work with?
Yes.
Yes, so actually right now we support Maven, we support pip for Python, and we work with the Debian APT tool, and there is no currently support for NPM, for example. But the framework is really designed to be extendable, so it should be doable. It's not part of the project right now, but we are really open to contribution, and so such implementation can be added. I would not say it's easy, but it can be included in the project.
Okay. Thank you very much.
Thank you. I think we can wrap it up. Thank you very much, Antoine. I think we have a few minutes before the next
Sorry,
talk.
I think I lost the sound, so I can not hear you anymore. It seems that the feedback is in mute. But I think the time is up, so I will I will stop now, and I thank you all for your attention, and of course I'm still open to questions if you have more later on. Thank you very much.
Thank you, Antoine. Bye-bye. Is Vigil Prevosto from the Software Institute at the French Nuclear Energy Agency. Virgile is an expert in software engineering methods, and his expertise lies especially in formal verification methods. Virgile is part of the Decoder Project, which he will introduce to us now. Over to you, Virgile. Is Virgile online? Well, they seem to be very busy up there in the technical room.
Okay, thanks for the introduction. So indeed, I will speak briefly about... Do you hear me?
Yes, Virgile, go on.
Do you hear me or not?
We can hear you.
Hello? Do you hear me?
Yes, but you don't hear us.
Okay, so seems to be a problem. Do you hear me or not?
Well, in the meantime, the Decoder project is Horizon 2020 research project that was started 3 years ago and is about to finish. So there will be a demonstrator available soon.
Okay, once again, I try. Do you hear me?
I invite you to follow up the website of the project, which is decoderproject.eu, where you will find the links to the testing campaign. They will have a beta testing campaign, which will enable you to discover.
Hello, can you speak, please?
We are sorry to announce that we have to skip this presentation because there are technical issues, unfortunately.
Okay, yes. Okay, do you hear me? I'm speaking right now. Okay. Okay, do you... Okay, thanks. And sorry for this technical problems. I will now try to present the Decoder project, hoping that everything works smoothly. So, as was already said, we are nearing the end of the project and wrapping things up. Basically, the idea was to provide a unified platform to manage all kind of information you want to have on a given code base in at all stage of the product life cycle. And for that, we wanted to rely on the one hand, software engineering tools, and on the other hand, natural language processing tools and deep learning based algorithms to explore what's in the code base, and having a good user interface to manage everything. Basically, this database is based on MongoDB, and on top of that, we have a certain number of APIs to be able to interact with the database, mostly on the form of an HTTP server and a RESTful API, which is available on the Git of the project under an open source license. I won't comment on that because it's pretty technical and we have lost some time. Basically, I will describe briefly the kind of tools you can find over the PKM. So at the bottom of the page, we have really program analysis tools, either static analysis in the form of the Pharmacy for C and C++ and OpenGML for Java tools to make proofs about programs. We have testing tools, especially for graphical user interface with Tester, and graphical debugger, formal debug, which I will present briefly in a short time. Then on the left, we have tools to deal with documentation and specification. So GMLGen will try to generate GML specification from Java programs. Code summarization will extract some information from the code base and propose some alerts over what might be errors. Code, so semantics role labeling will try to extract semantical information from the code in order to generate meaningful specifications. Finally, for the documentation, we have trace recovery tools to trace the links between the code and the high-level requirements, and tools to either generate documentation from semi-formal specifications or the reverse. So these tools can be used directly. You can interact directly with them, but it's also possible to use a process engine which will guide the users through some methodological steps that have been devised within Decoder. And it's possible to access the process engine from high-level front-end, one which is web-based and one which is based on the Jupyter notebooks. So this was all for the general platform. Now I will focus on a few of the tools that have been developed within Decoder. So the first one is a code summarization tool, which tries to extract the appropriate information from the code. And its main use so far is to try to identify what are possible misuse of a variable or of a field name in this, in the case that is displayed on the right of these slides, and provide suggestion for what the tool thinks would be a fix of the identified problem. So yeah, it's a simple instance where the method set username is trying to set the password field of the object, which is probably not what was meant in the first place, and the tool suggests that instead the field this.username should be set. So this works mainly on Java so far. Another tool that has been developed is the ability to find some correspondence between natural language documentation and the code that is supposed to implement what is in the documentation. So for that, the idea is, of course, to have a representation of the natural language sentence in the form of predicate and arguments, as is classically done for interpreting natural language, and to consider the code and possibly the formal specifications as another kind of very specific natural language for which a translation should be found. So this has been done for simple sentences within the project. Again, mostly on Java and C++ programming languages as targets. Together, so with the definition of the traceability matrix between high-level requirements, which are written in natural language, and the code. Finally, the idea is that we won't probably be able to go directly from natural language to fully formal specifications or code generation. And instead, we might want to have something in between, which is called within Decoder the abstract semi-formal models, which can be thought of as some kind of UML-like language with diagrams, invariants, and state machine description. There are some tools, as I said, to either extract ASFM from documentation with the help of the user and of the tools that are developed within Decoder, and possibility to generate documentation from an ASFM diagram. There are also tools that are able to generate ASFM templates from code, either by static analysis with the excavator or dynamic exploration of the code with tester. And the formal debug tool is able to make use of ASFM diagrams to provide an abstract view of the code under execution from a debugging session in order to have an easier view of what's going on inside the program, especially if you have a kind of a complicated state diagram to explore within this concrete execution. It's also able to interact with static analyzers that will give you not a single concrete execution, but a whole range of values for each of your variables. So it's basically a way to have an interactive view, interactive session with your static analyzer, and have a better comprehension of what the program is supposed to do. So finally, the front end, the main front end of the PKM comes in two flavors. One is browser-based and provides basic support for the main tools that feed the PKM. And by the end of the project, should be able to interact with the process engine instead of directly with each of the individual tools, so that it's possible to have complete sessions done directly through the process engine and not by activating in sequence a certain number of tools. You can also have a view of the traceability metrics from high-level requirements to code in order to check that your requirements are fulfilled. And there's also a possibility to have a Jupyter notebook indicating everything that you've done in a session with interaction with the PKM. In practice, these tools have been used inside Decoder over a certain number of use cases in C, C++, or Java. So this has been done for all the tools of the project, and also there have been some data sets extracted for the NLP and learning-based tools in order to make them more efficient. Outside of the project, there are two reach-out beta testing campaigns for the Doc2 JSON, so the name of the Doc2 ASFM tool, and the GMLGen generator of specifications that can be tried out by everyone interested. So in summary, there's now a robust infrastructure for the database itself. The tools are well connected, so the individual tools are well connected with the database. So there's an experimental version of the process engine that can now takes over the task of providing the sequence of tool calls to individual tools for a given
2 minutes still. Can you hear us?
Session, and UI.
Unfortunately not. We will let him still speak, and
to
then
guide everything.
we go on to the next
Basically,
speaker.
the idea is to extend the semi-formal models and the tooling, and improve usage of the tools, especially through new projects. And I guess that's all. So thank you for your attention, and sorry for this technical glitch at the beginning of the presentation.
Thank you very much. Virgil, you probably can't hear us. Can you hear us now?
Yes, there's some echo, but I can hear you.
Okay. We had some problems, technical issues, but I think your speech will be uploaded later in the full version, so also you who came now in presence and the ones online will find it there. But thank you very much, and I give now the word to Thomas.
Thank you, Anna. Thank you very much. Thank you, Virgile. And our next speaker is Davide. Shall I go now, or shall we start again? Because there is a countdown. I'm waiting for the countdown.
I think we can wait for the countdown and then introduce our next speaker.
Yeah? Well, start again. Well, thank you, Virgile. And our next speaker is Davide Albeto. Davide is an engineer at the Knowledge Labs of the engineering group. huge software house that I don't need to introduce here in this country. Davide has been working on the OW2 project right from the beginning since 2005, and he's going to introduce us the huge version that has been announced at SFSCon today, OW2 Davide.
Thank you. Is it okay? So, thank you. Hello to everyone. I am Davide Albeto from Ingegneria Informatica. I am an IT solution architect. I was involved in the design and development of Spago BI and Knowledge. For who doesn't know, Spago BI is the previous brand name of Knowledge. I joined engineering in 2005, as Cedric said, when my colleagues were releasing the very first version of Spago BI at that time. Today, I'm going to introduce you the new features of OW2 series, something we already implemented and something is going to be released very soon. So, for who doesn't know what OW2 is a full business analytical suite covering all business intelligence needs for our information discovery, information distribution, data visualization, analytical tasks, etc. It provides several analysis types, several visualization capabilities, starting from traditional static reporting that you can play live or you can schedule, produce in batch, and deliver by email. It provides interactive dashboards. It provides KPI engine to calculate the performance indicators of your business. It provides support to spatial data to display information over a map. And it provides also a data exploration tool that we call the QBE that the final user can exploit to query the data source in a visual way, just using drag and drop. Then it provides also a kind of data space for the final user where he can upload his own data, for example, a CSV or XLS file, and design dashboards on top of it. The OW2 7.4 version was introducing some interesting new widgets within the dashboard component. The HTML widget, where the developer can inject his own HTML and CSS code for full customization capabilities. The custom chart widget that can be exploited to use all the possibilities offered by the JavaScript libraries that are integrated within OW2, but also JavaScript libraries that are not released with OW2. The R and Python widget, this is intended for data scientists mainly. They can inject their own R and Python scripts for advanced data visualization, such as, for example, forecast, clusterization, classifications, and so on. The discovery widget that allows to query Solr indexes for full text search. The Solr is a very famous open source indexing and searching engine. In all those widgets, they are inheriting the data context from OW2. I mean, data, along with parameters and other variables, are injected by OW2. Speaking about OW2 series, here you can see a summary of the main pillars we are working with. As you can see, some capabilities are already implemented, other ones are in progress, and other features are in our to-do list. The main pillars are, the first one is about pre-built components, the second one is about cloud distribution, And the third one is about usability. Pre-built components, I mean some widgets, a gallery of widgets that can be reused when designing the dashboards. Functions within a catalog with R or Python scripts that can be used also by final users. Features for natural language interaction. Cloud distribution is about the availability of knowledge into the main cloud providers, Amazon, Azure, and Cloud, and also about certification of knowledge on the main data sources that those cloud providers integrate. It is also about providing more functionalities for the admin user to easily manage the knowledge instance from remote. Usability is about instead the general usability of the platform and also improving, adding new features to the self-service process. This process exploited by the final user to analyze his own data. The function catalog is something that we already implemented. It is intended mainly for data scientists to share their scripts, their R or Python functions that can be reused also by final users. I mean, when a final user is designing a dashboard, he will see the list of already implemented functions and he can exploit those functions. For example, adding a forecast column on his data set and to display that column on a traditional chart or a table or a map or whatever. Also, the gallery is something that we already implemented. It is conceived to contain custom widgets to be reused. The widget I spoke just before, the HTML widget, the R Python widget, and the chart widget. The idea is to use portions, scripts of code as a template. So, for example, a final user, when designing a dashboard, will be able to start from scratch or to start from an already existing widget. And of course, he has to adapt the template on his data context, on his data set. Cloud distribution, as I said, is about availability of knowledge in the main cloud providers. At the moment, knowledge is available on Amazon. It will soon be available also on on Google and Azure. We already certified knowledge on different data sources. For example, Amazon Aurora, Amazon Redshift, Google Cloud Spanner, Google BigQuery, and Azure Synapse Analytics. More about this, we are developing some features for the admin, for the administration tasks, and we are changing the license to a floating license model. A note here, knowledge is released in two different editions, the Community Edition and the Enterprise Edition. Community Edition is free and open source software, available under the terms of the AGPL license, and the Enterprise Edition is commercial, and it is adding more administration capabilities, advanced administration capabilities mainly. For the final user perspective, there is no very big difference between the two. Natural language interaction is something that it is in our to-do list that we are going to work very soon. The idea here is to provide some help to the final user in his daily activities with knowledge. For example, discovering the analysis he is looking for to understand what he is looking to understand better. We will exploit all the metadata, the technical metadata and the business metadata to provide all information to the user. The chatbot will be based on a template, a conversational template that has to be developed project by project according to the specific business domain. Currently, we are working on a data preparation tool. The user will, when starting from a data set, he will be able to adapt, to transform the data, maybe an XLS file or an enterprise data set. For example, adding a calculated field, cleaning some data, replacing some values, splitting, grouping, filtering, etc. It is, let's say, a simplified ETL process intended for final users. Here you can see the milestones. We already released the 8.0 version. We have the widget gallery, the function catalog. We have many data sources already certified, and the resource manager. Currently, we are working on the data preparation tool. We are reviewing the user interface to improve the usability and the performance. And we are developing some new features for the self-service process. Version 8.1 will be released beginning next year with all the other features I already showed you. So thank you for your attention. Of course, if you have any question, do not hesitate. Thank you.
Thank you very much. I invite you who are in presence to come forward if you have a question. Is there anyone? Okay, no, we also don't have a question online, so thank you very much.
You're welcome.
Welcome back. Our next speaker is Yubinkui of Huawei. His career took him from H3C in China and China Mobile, and now at Huawei. Yubin is based in Brussels and will introduce the OW2 Quick App initiative. Yubin, over to you.